Brownie. Nice to see you all, at least your little faces on the screen. So, well, as you can see, the title of my talk is The Quantum and the Greek, the return to Greek philosophy in the works of Heisenberg, Pauli, and Schrödinger. My talk boils down to we should read the Greeks. It is important even for contemporary philosophy of science, and it is not me saying it. It is Heisenberg, Schrödinger, and Pauli's words. So first, I have to apologize for my PowerPoint that is basically a bunch of quotes. We'll be revising some texts by the three authors, and since I know it is impossible to follow read quotes, I'm giving you the opportunity to follow them if you want to. So not a pretty PowerPoint, hope it helps. So I know it could seem a bit strange, a bit extravagant to defend the importance, the great value of ancient Greek philosophy for quantum physics, of the oldest philosophy for the newest science. But this impression is, however, very rapidly dissipated when one reads the works of these three main figures in the development of quantum mechanics. The three of them exhibited a strong and insistent interest in Greek philosophy, and they claim that this interest was not at all separated from their work in the new quantum theory. So why was the revision of Greek philosophy so important for them? Why were Schrödinger, Pauli, and Heisenberg so interested in ancient Greek philosophy while working on the quantum theory? So let's take a look at one of Schrödinger's simplest reasons in Nature and the Greeks. He says, by the serious attempt to put ourselves back into the intellectual situation of the ancient thinkers, we may regain from them their freedom of thought. So the challenges quantum physics had set in front of these physicists from the early 20th century couldn't be tackled with the customary way of thinking of their science of their time. So they needed a broader way of thinking. They need to recast the parameters, completely recast the parameters of understanding nature through science, an approach less burdened by the customs of their time. So in order to achieve that, a jump back beyond the beyond modernity and into this lively Greek source seemed to them a proper means. As we will see, the Greeks always appear in their works in explicit contrast with modern philosophy and science. The Greeks have a critical and a constructive role in these three physicist works. In a critical sense, they serve as a contrast with modernity that allowed them to clearly identify the problems with the concepts and separations of modern science. And they also have a constructive role inspiring this recasting of their understanding of nature through science. In any case, aware of the oddness of the attempt, Schrödinger tells us that when speaking about the subjects he later wrote in Nature and the Greeks, he felt the need to explain himself. He said, there was need to explain that in passing the time with narratives about ancient Greek thinkers and with comments on their views, I was not just following a recently acquired hobby of mine. That it did not mean from the professional point of view a waste of time, which ought to be relegated to the hours of leisure. That it was justified by the hope of some gain in understanding modern science and thus, inter alia, also modern physics. Less preoccupied by appearances, Heisenberg goes even further and says one can hardly make progress in modern atomic physics without a knowledge of Greek natural philosophy. So one hopes the other one is certain, but they both point to the same issue, the same idea. This progress, these advancements, the new theory is conditioned, or in any case assisted, by a knowledge of the of Greek philosophy, of the old, of the origins of science and philosophy. So without the ability to pose again in an original manner questions of principles, without the ability to shake off some modern presuppositions gained by the knowledge of the Greeks, they thought it was difficult to tackle the new challenges of quantum physics. In this point, it is interesting to recognize the contrast between the common views of Schrödinger, Heisenberg, and Pauli, and the widely accepted vision today in scientific context and also in philosophy of science, according to which science, properly speaking, originated in modern times in the 17th century. Now, these physicists from the early 20th century did not see what began in the 17th century and was developed over the 18th and 19th century as the origin of science, but rather as the origin of some of the specific parameters of modern science that quantum mechanics, among other developments, was rejecting. So enlightenment, however admirable, was for them the establishment of a certain view of science that had become problematic. And they saw, in some senses, better allies in the Greeks. So in their works, they make this contrast frequently explicit. No? This distinguish between the aspects of modern science that seem now problematic and the ancient Greek model that could help them overcome this obstacle. For instance, Kant's a priori concepts and forms of intuition were no longer sufficient. The Cartesian division between res extensa and res cogitans seem now a bit naive. The growing separations between physics and philosophy, between scientific experience and metaphysics, seem an obstacle to develop a new way of thinking. And so to gain a critical point of view regarding modernity and to broaden this understanding of making science, they found a key in Greek philosophy. But that is only a general answer. We will try to analyze this question, this return to Greek philosophy, in relation to three particular issues. I don't know if we'll cover the three. I'm hoping we can cover two of them. But one is a question of understanding. They turn to the Greek to recuperate a broader perspective on what it means, an original perspective on what it means to understand nature through science. Another issue leading them to the Greek was separation. They turned to the ancient Greeks, trying to find a way out of the extremely compartmentalized and separated scientific landscape. And another very different reason was related for them not to its role, not to the role of Greek philosophy inspiring new physics, but rather, according to that contrast with modern thought, to the critical analysis of some ancient Greek philosophies that were taken in the basis of modern science and that seem now problematic, especially atomism. So they went back to ancient atomism to analyze how it passed to modernity and how it was now problematic. So let's start from that last issue. Schrödinger, explaining the different motives for the necessary study of the Greeks, distinguish especially two reasons. On one hand, he hopes they can inspire us to reunite what is separated, mainly he says philosophy and science, that for him shined as a unity in the Greek philosophers. But the second reason aims at producing at the same time a critical analysis of what turned out to be problematic in the influence of Greek thought over modern science. There's no question that for Schrödinger, but also for Heisenberg and Pauli, the Greek philosophy that most strongly and effectively informed the basis of modern physics and that appear now as extremely problematic was atomism. Schrödinger, but especially Heisenberg, take the time to really thoroughly analyze ancient atomism. It is interesting, for instance, the contrast Heisenberg does between Parmenidean philosophy and atomism, and he shows how atomism simply postulates what Parmenides forbidded, that is the existence of not being, and Schrödinger shows how atomism was simply like a postulate to prevent the mathematics of infinite indivisibility to make the analysis of the physical world so problematic. So they were showing already the critics atomism received in the ancient times. But let us focus on the description of how atomism passed to modern science. Schrödinger writes, from the lives and writings of Gassendi and Descartes, who introduced atomism into modern science, we know as an actual historical fact that in doing so, they were fully aware of taking up the theory of the ancient philosophers whose scripts they had diligently studied. Furthermore, and more importantly, all the basic features of the ancient theory have survived in the modern one up to this day, greatly enhanced and widely elaborated, but unchanged, if we apply the standard of the natural philosophy, not the myopic perspective of the specialist. So those who established the basis of modern science found this ancient theory useful, so it became a fundamental part of this intellectual edifice they constructed, and that in some senses lasts to our days. And Heisenberg also describes this path through which atomism passed to modern science, and he especially analyzes how it was united with the materialistic view that began to take form in the modern times, that separating reality in res cogitans and res extensa limited physics to the study of these mechanics of this now merely material res extensa. So I'm going to read just the last part of this quote. He says, it is thus that there arose the oversimplified worldview of 19th century materialism. Atoms move in space and time as a real and immutable substance, and it is their arrangement and motion that create the colorful phenomena of the world of our senses. So Schrödinger too sees this modern atomist worldview as naive. He claimed that the term atom had become a misnomer, and he stated the fact that was becoming evident for those involved in the development of quantum theory. He says, modern atomic theory has been plunged into a crisis. There is no doubt that the simple particle theory is too naive. So what was once a basic assumption for physical thought was not now exposed as an inadequate postulate, and one that represented the great obstacle for the theory. But I believe it is perhaps Heisenberg who explains most clearly why the atomic postulate began to fail in quantum theory. He says, let us discuss the question, what is an elementary particle? We say, for instance, simply a neutron, but we can give no well-defined picture and what we mean by the word. We can use several pictures and describe it once as a particle, once as a wave, or as a wave packet. But we know that none of these descriptions is accurate. Certainly, the neutron has no color, no smell, no taste. In this respect, it resembles the atom of Greek philosophy. But even the other qualities are taken from the elementary particle. At least to some extent, the concepts of geometry and kinematics, like shape or motion in space, cannot be applied to it consistently. If one wants to give an accurate description of the elementary particle, and here the emphasis is on the word accurate, the only thing which can be written down as a description is a probability factor. So quantum physics goes much further than ancient atomism, which deny qualities as smell, color, or taste to their elementary particles. Now even shape or motion are discarded. So what are we left with? The particle loses in quantum theory almost all of its defining characteristics. As Schrödinger writes, it even loses sameness. He says an elementary particle is not an individual, it cannot be identified, it lacks sameness. So there's almost nothing left of it. And what's left of it is certainly an aspect that doesn't seem too adequate to atomism, that could perhaps be better understood outside of the atomist frame. A strange probability that we can interpret in a classical manner as an abstract probability dependent on our degree of knowledge of an actual real particle. So in one instance, trying to provide a new understanding of this quantum probability, Heisenberg finds a possible ally in another Greek philosopher, in Aristotle, and in his concept of dynamis, which is normally translated as potency. A concept that modern physics ignored to focus only on the characterization Aristotle did of the actual way of being. And we should add that this example is quite representative of the conflict between the relation classical physics had with Greek philosophy and the relation quantum physics called for. Exactly what was excluded, regarded as problematic by classical physics, Aristotle's concept of potency, for instance, became for those who were developing the quantum theory an interesting possibility. And what for classical physics functions so well, mainly the principles that for Aristotle define the formal and actual aspects of entities, like the principle of identity, non-contradiction, or even atomism, became for quantum theory naive and inadequate parameters. But Heisenberg, besides this brief speculation on Aristotle, actually attempted to develop a radically different atomist view, a peculiar non-materialistic atomism based on the philosophy of one who actually very much rejected atomism, who wanted to see all atomist works burned down. This was Plato, of course. And it is safe to say that the Timaeus was one of the philosophical works that most influences Heisenberg. In Physics and Beyond, he describes his whole intellectual itinerary as stations in his understanding of Plato's Timaeus. And focusing on this dialogue, where through the character of Timaeus it is proposed that geometrical forms are the building blocks of corporeal reality, Heisenberg sees a Plato that develops Pythagoreanism in a new way, providing a different atomism built now from mathematical forms and not from indivisible bodies. A Platonic atomism that he believes could be better related to quantum mechanics. He says, our elementary particles are comparable to the regular bodies of Plato's Timaeus. They are the original models, the ideas of matter, as nucleic acid is the idea of the living being. These primitive models determine all subsequent developments. They are representative of the central order. So, but as interesting as this Platonic atomism may be, one can't help but to wonder why the insistence on developing an atomist view? Why this obligation persists, even if there is nothing to support it? Why not leave atomism aside altogether? I think it is Schrödinger who finds an explanation for this fixation on atomism. He writes, atomism has proved infinitely fruitful. Yet the more one thinks of it, the less can one help wondering to what extent it is a true theory. Is it really founded exclusively on the actual objective structure of the real world around us? Is it not in an important way conditioned by the nature of human understanding, what Kant would have called a priori? So this worldview that seemed to describe the fundamental nature of physical reality started to appear, at least for Schrödinger, rather as a presupposition that constantly and inadvertently condition our way of thinking and our way of perceiving. And it was most inadequate. He said, we have taken over from previous theory the idea of a particle and all the technical language concerning it. This idea is inadequate. It constantly drives our mind to ask information which has obviously no significance. So to follow the association with Kant's terminology, we can say that atomism appeared now as a dogmatism, as a metaphysical presupposition assumed without criticism. So criticism seemed then to be in order. So why do we still hear today with such certitude that quantum mechanics talks about elementary particles? I believe because for the most part this critical task was prevented by the influence of Bohr and of positive philosophy. So the critical analysis of classical concepts and the subsequent development of new systems of concept was limited for Bohr, who claimed that the only language for physics could be the language of classical physics. And at the same time, positive philosophy evacuated metaphysics from its role, its fundamental role in scientific theories, and turned it into just a mere storytelling one can add, but most inconsequentially, to an already functional empirical theory. So in this way, atomism, instead of being the object of that criticism that Schrödinger alluded to, was crystallized in a dogmatic manner as a basic presupposition not to be questioned again. And at the same time, as all other conceptual endeavors were mere storytelling, there was no place for a critical analysis of this presupposition. And this presupposed atomist view is, as Schrödinger pointed out, the source of many of our missteps. It still makes us see what we don't see, actually, to see a particle when a spot appears in a plate or a click happens. It makes us ask the wrong question and give the wrong answer to already very problematic question. So let us move to the second issue about understanding. So as we said, they knew they were not faced only with new discoveries that would help complete the mosaic of modern physics. They were faced with the complete disconnection between what was being developed in quantum physics and the previous theoretical parameters as they were expressed not only in explicit scientific theories, but also, as we showed with atomism, in the presupposed worldview that informed and gave sense to the perceived physical phenomena. I would argue that we are still kind of in the same situation. So the systems of concept that allow to relate consistently experience to its principles, the fundamental concept that permitted to understand phenomena as part of an order, those fundamental parameters of modern thought were now, in many aspects, inadequate. So for this physicist of the 20th century, it was important to revise how that modern representation came to be, what is supposed, how to produce a different system of concepts that allowed for understanding of quantum phenomena. But of course, by that time, they have at their disposal a quite practical response to this question, an easy way out. The positivist renounce the rejection of the possibility of understanding nature and the redefinition of science as merely a coherent record of observations. Schrödinger writes, "One would, in this context, have to discuss the question, what does comprehensibility really mean? And in what sense, if any, does science give explanation? David Hume's great discovery that the relation between cause and effect is not directly observable and enunciates nothing but the regular succession, this fundamental epistemological discovery has led the great physicists Gustav Kirchhoff and Ernst Mach and others to maintain that natural science does not vouchsafe any explanations, that it aims only at and is unable to attain to anything but a complete and economical description of the observed fact. This view, in the more elaborate form of philosophical positivism, has been enthusiastically embraced by modern physics." It is interesting to point out, although we don't have the time to develop this further, that many central aspects of positivist philosophy also had their origin in Greek thought, mainly in the Greek sophists, as was already explicit in the manifesto of the Vienna Circle. So in any case, what is certain is that for Schrödinger, for Pauli, for Heisenberg, but also for Einstein, that this positive solution for the question of understanding is not possible. Einstein, for instance, see this economic principle defended by Mach as too naive. But the main issue with positivism is, for all of them, its simplistic concept of observation. Now they will respond to Mach what Kant added to Hume. Observation is in itself theoretically laden. Observation cannot be taken as innocent givens. Kant argued that causality is surely not directly observable, but it always determines observation, and a priori determinations, such as causality, are what makes experience and objectivity possible. These a priori conditions are part of all observation for all subjects. So Mach wishes to banish a priori concept and stick to observation, but by this attitude, he actually helped make the modern concept unconscious, unanalyzed. In a conversation they held in 1925, Einstein explained to Heisenberg that in fact it is only the theory which decides what we can observe. And as you see, Pauli also insists on this matter. Personally, I do not see how it is possible to give a definition of the phenomenon in physics which seeks to isolate the data of perception from rational and ordering principles. It seems to me that rather that the separation of this sort is itself already the result of a special critical mental effort which removes the ever-present unconscious and instinctive ingredients of thinking. So positivism was not a solution. It only rendered these modern concepts unconscious and analyzed, but at the same time, the Kantian solution, the Kantian concepts were not adequate no more. So in fact, Kant appeared as part of the problem. New allies were needed. The new discovery violated Kant's a priori conditions. There were in fact experiences that could not be subsumed under Kant's categories, under Kant's forms of intuition. So what was previously seen as the conditions for all possible experience appear now as the conditions of a specific understanding, specific and limited understanding of science. Pauli says, we agree with Pierre Bernays in no longer regarding the special ideas which Kant calls synthetic judgments a priori, generally as the preconditions of human understanding, but merely as the special preconditions of the exact science and mathematics of his age. So faced with the crisis of these modern parameters of knowledge and experience, some of these physicists turn instead beyond the modern source to the original source. They jump back to ancient Greece in order to rethink scientific understanding all over again. Heisenberg in Physics and Beyond reconstructs the words of a young Pauli precisely when he was talking about what understanding meant when stripped down to its most essential meaning. He says, understanding probably means nothing more than having whatever ideas and concepts are needed to recognize that a great many different phenomena are part of a coherent whole. Our mind becomes less puzzled once we have recognized that the special, apparently confused situation is merely a special case of something wider. The reduction of a colorful variety of phenomena to a general and simple principle, or as the Greek would have put it, the reduction of the many to the one, is precisely what we mean by understanding. The ability to predict is often the consequence of understanding, of having the right concepts, but is not identical with understanding. So understanding is having the adequate concept that allow to consistently reduce phenomena to a coherent whole.
Raimundo, as you asked me, you have 5 minutes.
Okay. So, as also remarked by Heisenberg, for understanding of the phenomena, the first condition is the introduction of adequate concepts. Only with the help of correct concepts can we really know what has been observed. So, but classical Kantian concepts are not adequate. They are no longer capable of consistently relating and representing phenomena. We need concept, but not the classical one. So, how to do? Where to look? Heisenberg says we could learn much from the Greeks. They could teach us how to look. What always distinguished Greek thought from that of all other peoples was its ability to change the question it asked into questions of principle, and thus to arrive at new points of view, bringing order into the colorful kaleidoscope of experience, and making it accessible to human thought. Whoever delves into the philosophy of the Greek will encounter at every step this ability to pose questions of principle. And thus, by reading the Greeks, he can become practiced in the use of the strongest mental tool produced by Western thought. So this is, of course, what they needed to regain the ability to pose questions of principle. So this fruitful strategy we kind of take for granted, this methodical yet artful ability to arrive at the unities inherent in multiples and to proceed with these principles in a way that enables us to understand the world by ourselves. This is what the Greeks created. This is what produced our intellectual strategy and attitude. And we have to, as the Greek teachers, as Plato's teachers especially, we have to exercise this ability to become practiced in it, not to renounce to it. And the Greeks show us that there is not really a system of rules to arrive to a metaphysical system of concepts. It is possible, but it is a dialectical process. But it is necessary, or without it, there is no understanding. So let us do a brief, quick history of Greek philosophy. So the first expression of this ability directed the Greek thinkers to the question of physis. This term is generally translated as nature. It encompasses not only what we say when we speak of nature in an extensive way, as reality as a whole, but also when we say something like the nature of reality, that means the essence. So for nature is for the first Greek philosophers at the same time something dynamic, changing, which at the same time responds to some internal order or element or substance. And this internal, this order, this essence of reality, according to which reality develops, is what they seek to understand. So while for Kant, reality's order criteria came from subjective conditions, from the subject, for the Greeks, these conditions were real themselves beyond the subject. So some of these first philosophers proposed an element, a substance, from which reality could be developed and understood. Aristotle calls them the physicoi, or the physiologoi. And Schrödinger also points that our scientific attitude has its origin with the physicoi. We can translate physicoi as physicists, actually, or as naturalists. And after the physicists, the Heraclitus redirected this search for the fundament of physics no longer to an element as water, air, like the previous physicoi, but to the description of an internal order that rules physics. And he allusively described this order and called it logos. So this denomination is very significant for the development of philosophy, because until Heraclitus, use of the word logos had a meaning strictly related to language. Discourse, argumentation, account, even tale. In all of these translations, we see, however, something that will be essential to all meanings of logos, even when it doesn't refer to language. This is a significant combination, a reunion with criterion, a collection with purpose. Logos never means isolated words or a meaningless sentence or dispersed words. It always refers to a combination that is that has a reason that is able to produce an effect or a meaning. So we now understand why Heraclitus chooses logos to describe this order of reality. He sees in reality exactly that. A combination that is not meaningless dispersion, but that responds to a criterion, to an order. So this double meaning of logos is very interesting. There is the logos of human beings, the discourse, and the logos of physics. And this represents a kind of affinity between them that allows for knowledge. So it is not easy to say the logos of physics in our human logos, since, as Heraclitus says, physics loves to hide, but it is nonetheless possible. And then finally, Plato develops this further, and he renders these logos of physics more precise. It is no longer described in a general manner. Now as the Heraclitean opposites intention, and the path to its knowledge is not so obscurely alluded. It is methodically developed. So what Heraclitus calls the logos of physics is for Plato the realm of ideas. Ideas are the elements, the forms that populate this central order. These ideas are different. Each one is to be found and known through particular dialectical efforts. And they have different relation among them and with phenomena. And they allow for more than an elusive general assessment of unity in nature. So in any case, what I wanted to show is that this Platonic development, generally known as his theory of ideas, is what Pauli reinterprets and with Jungian aspects elaborates on, trying to go past these Kantian limitations. So he says, with Plato's philosophy in mind, I should therefore like to suggest that the process of understanding nature, as well as the happiness that man feels in understanding, that is, in the conscious realization of new knowledge, should be interpreted as a correspondence, a coming into congruence of inner images pre-existent in the human psyche with external objects and their behavior. The bridge, which cannot be constructed by pure logic, rests, according to this conception, on a cosmic order independent of our choice, an order distinct from the world of phenomena, embracing psyche as well as physics. So, understanding is this coming into congruence of persistent images in human psyche and external objects and their behavior. This seems rather Kantian. This seems the same thing as Kant said. But these convergent forms are not originated of the subject and consequently are not limited to the parameters of the modern subject. They are now related to a cosmic order, which is expressed as well in human psyche as in physics. So understanding is a process by which the form we read in phenomena show that affinity correspondence with something we recognize in ourselves, and this is made possible by a cosmic order, an order which by this process is made available for us for our knowledge. So in any case, and I finish with this, as other philosophers in the same time as, for instance, Walter Benjamin, were also attempting, Pauli is in a way Platonizing Kant. His strategy is kind of Platonizing Kant by broadening the conditions of understanding to allow more than just the modern mechanical experience that Kant's a priori determination justified, and by relocating these conditions outside of the subject. He says, according to the conception here put forward, the a priori characters of Kant's rationally formulated ideas laid down once for all is as transferred to the pre-existent images, archetypes, present and operating outside of conscience. I'm sorry. So I'll finish with that. Thank you.
Thank you very much, Raimundo. We have time for questions now. I see that Otávio already raised his hand. So, Otávio, please.
Oh, thanks. I really liked the talk. Actually, I found it very informative and insightful in terms of thinking about some of the motivations that the founding fathers of quantum mechanics had to look back at ancient Greek philosophy. I think actually it speaks volumes about the kind of physicists that they were. Right? You cannot imagine current physicists, even being bothered to do that. So I thought actually it was quite interesting. Now, one question I have is, to what extent we, perhaps not they, but we should be aware of issues about incommensurability, right? The kind of conceptions of atoms, particles that we find in ancient Greek philosophy connects with what eventually became the conception in quantum mechanics, right? And that becomes very telling. For example, in one of the quotes you provide from Heisenberg, when he says, well, there are certain features about elementary particles that resemble the Greek conceptions, and you sort of isolate some of the properties. But if you want to be really precise, you have to think in terms of some probability distribution. And of course, at that point, you realize he's talking about something completely different, right? That only resembles the particles because, because of a name. They're considered atoms in some sense, but he's actually running with it in a completely different way, right? So what should we make of this?
I think it's very interesting that they keep using the atomist language. I think it is mainly because of Bohr influence, because atomism is not the only natural philosophy available, the only concept available to describe physical nature, and it is, as they claim, it is evidently inadequate. It has more obstacles that usefulness for quantum mechanics. So I think it is strange. It is very, very telling that they are very lucid in criticizing atomism, in going back to ancient atomism, even to really understand and criticize the theory that it is one metaphysic possible. And at the same time, they insist in talking about particles and atoms, about things that like Heisenberg, Platonic atomism has nothing to do with atomism. And I think maybe it is because of the influence of Bohr that he was able to keep the atomist a classical language and at the same time render it completely inconsistent and incoherent. He said he was generalizing a classical language, but it was making this language still exist. And the problem is that it is not just a way of speaking, it's not just a way of talking, it's a way of thinking and perceiving. So when we see something in an experiment, we see, oh, we see a particle, and you have made all the errors already in doing that. You have assumed a lot of things. You have assumed that you have to have a certain binary quantity here. You assumed you had little bodies here. So it is not the only possibility. That is what I wanted to point in these particular quotes.
Thank you very much.
Yeah, of course.
Thank you very much. Now, Diederik, please.
I liked very much your talk and very intriguing. These reflections on, well, I knew some of Schrödinger's writing there also. I have the following question. Whether it makes sense to think that eventually the Greeks and the pre-Socratics, even more than perhaps, they were probably in a period of time when Copernicus didn't exist yet. Well, there were some Greek philosophers who went in that direction, even Greek physicists and philosophers. But they were confronted with the life on Earth, which was much more complex, actually, than what we now believe is the life in the universe, which is dead matter, and so that would it make sense to think that is what made their thinking also actually more complex than what happened by classical physicist a la Newton pre-quantum, you see? I don't know if
why would you say I understand the question, but I understand why do you say that they lived in a more complex
well,
time?
they had to try to understand the world by looking to living things, to society, to culture. And while the pre-quantum physicists a la Newton, they try to understand the world, what we call naturalism now, but the kind of starting with dead matter as the foundation.
There's the third part of my talk that I didn't get to present was to point the problem with separations in modern science, and how, for instance, for Schrödinger, the Greeks showed a way of going back to a less separated understanding of nature, as you say, where it relates to other subjects as well. For instance, the Heisenberg criticized the separation in modern science by Descartes between res extensa and res cogitans, and the limitation of physics to this now merely material res extensa. For Heisenberg, that is a problem, and he makes the contrast between that separation and the unifying criteria of the ancient Greeks. So maybe this way of relating, of not separating the world, not separating philosophy from physics, not separating metaphysics from experience, in the ancient philosophers gave them another way of thinking about the world that is maybe, as you say, more complex or more unifying.
Starting from a bottom line, which is more complex, let's say. I was thinking when I listened to your talk, because when I was working still in Geneva, Piron would often say, Constantin Piron would often say to me, you should read Aristotle to know about potentiality and properties.
Yeah.
Well, anyhow, if you have written down some of these things, I would like to read more.
Yeah, I can do as Christian. There's an article that is more complete. I will leave it here in the chat, so you can.
Yeah, okay. Thank you.
Read it. There you go. I think.
Yeah, I see it.
So if that's all, let us thank Raimundo once again for his awesome talk.